Okay, welcome to the last week of term, and this week we've got 2 lessons to do in our unit on surds and indices, and the first of these is on scientific notation and significant figures. Now, the thing I want to make really clear first up is scientific notation and significant figures are 2 different things, but they often get used together. So just like addition and subtraction are different things, but often they get used together. All right, so just because something's in scientific notation doesn't mean that significant figures necessarily have to be used, but often they obviously are. So we just want to, as we go through this lesson, understand the difference between the two. And certainly significant figures are often used even when we're not using scientific notation. It's very rare it goes the other way, but very often you'll be asked to put something in significant figures, and that has nothing at all to do with scientific notation unless the question actually asks you to use scientific notation. That being said, we're going to start off with scientific notation in this lesson. So we use scientific notation because really writing really small or really large numbers like the mass of a molecule of water or the distance to a faraway planet in normal terms is just confusing. And even still, when we start talking about nanograms and micrograms, often people get confused. So we can use a unit of measure that people are familiar with, but we can use scientific notation to express a really small number in that unit or a large number in that unit. So as we go through here, there's a few examples, and we can see that 320 is just 3.2 times by 100. Now with scientific notation, we're always trying to get the number to be between 1 and 9.9, essentially, basically between 1 and 10, but we never use 10. And then everything else sort of goes beyond the decimal point. So we can think of 320 as 3.2 times 100, and 100 is 10 squared, so we end up with 3.2 times 10 to the power of 2. And the next example there of 408,000, well, that's basically 4.08 lots of 100,000. And 100,000 is 10 to the power of 5. Every time 10's raised to a power of 0 is added. And 6 million is 6 lots of 1 million, so we can think of that as 6 times 10 to the power of 6. So as we go with that, 34,000, well, that's going to be 3.4 lots of 10,000. And of course 10,000 is 10 to the power of 4 because there's 4 zeros there. So that's just going to be 3.4 times 10 to the power of 4. Our next example is 2,457. Well, that's 2.457 lots of 1,000. 1,000 is 10 to the power of 3 because there's 3 zeros. So we've actually got 2.457 times 10 to the power of 3. And the next example we get there is, I don't even know what that number is, to be honest, but it's going to be 9.8 lots of 1 with, what do we got? 3, 6, 9, 12, 15, 18 zeros plus 1 extra for the movement from here to there. So 19 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 18, 19. My gosh, that's a lot of zeros. So I wouldn't really want to write that number out. But obviously, because there is 19 zeros, it's 9.8 times 10 to the power of 19. So the question here is, can you see a shortcut? And I've just paused there because I plan on using Edpuzzle, and I'd like you guys to have a go at that. So assuming you've come back from that, you hopefully have realised that we've moved the decimal place 1, 2, 3, 4, 5, 6 times. So it's going to be 4.5 times 10 to the power of 6. So for every point you move the decimal, every place you move the decimal point, that's going to be your power of 10 that follows your number in scientific notation. So those examples were all of really large numbers. Now we're going to deal with really small numbers. So think of these examples here. 0.004 we can represent as a fraction, and we represent as a fraction as 4 1,000ths. And of course the 1,000 is just 10 to the power of 3, so it's 4 divided by 10 to the power of 3. So we can display that, if you remember from doing indices, that this is basically going to be 4 times by 10 to the power of negative 3. I guess that comes in there. So we know that when we've got a negative power, it's we cross the line and change the sign. It's going down into that denominator. And likewise, you can see your way through those first few examples there. So we'll run through the fourth one. So we're going to have 6, and that's in the 10,000ths column. So 6 divided by 10,000 is how I could display that number. And 10,000 is just 10 to the power of 4. So I'm going to end up with 6 times by 10 to the power of negative 4. For this next example, I've got 2 over, now we got 1, 2, 3, 4, 5, 6, 7. So 2 10,000,000ths, essentially. So I can write that as 2 over 10 to the power of 7. And that becomes 2 times by 10 to the power of negative 7. And then finally, I've got, in this case, I'd write that as 7.2 over 1, 2, 3, 4, 5, 10 to the power of 100,000, or sorry, 100,000. So it's in the 100,000ths column. So it's going to be 7.2 over 10 to the power of 5, which we're then going to write as 7.2 times 10 to the power of negative 5. So we only want that number on the left-hand side here. We only want that number to be between 1 and 9.9. So once again, we're asked, do you see a shortcut? Well, the shortcut I think we're seeing is that every time we move the decimal place, 1, 2, 3, 4, 5 times we have to move it. So we end up with 4 times by 10 to the negative 5. Just for every time we move the decimal place, that's what we're changing there. So we can then convert these numbers into decimal form. So going backwards, if I can write 5.6 and it's times 10 to the power of 3, so it's going to get bigger. I bounce my decimal place 1, 2, 3 times. So now my decimal place is going to end up there. I'm going to have to fill the gap in with zeros. So I'm going to end up with 5,600. For the next example, 10 to the power of negative 5, if I write the number back out again, and I have to bounce the decimal place 5 times, this time to the left. 1, 2, 3, 4, 5. So now my decimal place is there, so I'm going to need to fill in all these gaps with zeros. I'm going to equal 0.0000107. Okay, now we can do this with our calculator. And I'll just bring up my calculator here so I can show you that process. So if we take that number that I just wrote in there, what was that? Sorry, I'm just moving my calculator up here. So 0.0000107 and press equals. If we want to get the calculator to do the heavy lifter here and change that into scientific notation, we can go Shift, Setup, and here under 7 is SCI, which stands for scientific notation. So we press on that and then we say how many significant figures we want. Now in this particular one, I'm going to get 3 significant figures, just because I know that will work out nicely for us. And you can see that's 1.07 times 10 to the negative 5, which is just what we've got here. Okay, and then if we want to display it back in decimal form, then I just need to go Shift, Setup, and go back to normal. So you've got scientific notation or normal, and just choose the number 2 there. And we're back to how we started. So that's how you can use your calculator to switch between the two. If I'm entering something in scientific notation, say I'm doing a calculation, I use this button down here. Don't use times 10 to the power of, don't use the Xbox button up here. Use this times 10 to the power of button, and then we put -6 there, and that'll make that number work out nicely for us. Make sure you're using that times 10 to the power of button, which is you've been using a lot up until now to use for pi. Obviously Shift and that button gets you pi. Okay, so moving on to significant figures now. Significant figures is just a way of rounding things, and we're just concerned with, I guess, coming towards the number from the left to the right and counting the number of non-zeros that we hit. I guess not non-zeros, not counting any zeros that we hit, and then once we start hitting some non-zeros, we then start counting all the relevant digits. So if I came along in my car and ran into this number, I would go 1, 2, 3, 4, 5 significant numbers. I don't care about all the other digits that might be involved that we don't write down there. There's zeros above, zeros in front of that 3. There's a decimal point after that 1 and zeros after that. And I don't care about any of those. I just care about those 5 significant figures there. So the second example has 2 significant figures because I don't care about all these zeros that I run into until I start hitting something other than 0. So 1 and 6 are our 2 significant figures there. In the third example, that's in scientific notation, it has 3 significant figures. It has the 1 before the decimal point and the 2 after. Now, 256,000, we really need to know more information. I don't know if those zeros are significant. So if we'd counted to the nearest 1,000, then we've got 3 significant figures. If we counted to the nearest 100, then we've got 4 significant figures. If we counted to the nearest 10, then we've got 5 significant figures. Or if we counted to the nearest unit, it just so happened that this particular thing was exactly 256,000, then we have 6 significant figures. So to determine, you've got to know how the measurement was taken. So moving on to our next examples here, state the number of significant figures given in these numbers. So if this was rounded to the nearest 10 and I've come along and hit this number, I've counted 1, 2, 3, 4, 5 significant figures. Because it was rounded to the nearest 10, there's only 5. That 0 in the units column is not significant. We didn't measure units, we only measured to the nearest 10, so that's got 5 significant figures. And then thinking about this one, I don't care about the decimal point. I'm just going to come along and go, well, how many significant figures is there? There's my first one, my second, my third, and my fourth. The 0 still counts if it's in the middle of the number, so there's 4 significant figures. This one, once again, I come at it from the left. The first number I hit is that one. That's the second number. That's the third number. So I've got 3 significant figures. And finally, coming from the left, I hit that number 1. That's the first number I notice. The 0 still counts because of the 3 there. All right, so I need those zeros because that 3 is significant. So I've actually got 4 significant figures in that particular instance. So now we need to write numbers in scientific notation and 3 significant figures. So if it's scientific notation, first of all, how many places I'm moving the decimal place? 1, 2, 3, 4, 5, 6, because I want just the number to be between 1 and 9.9. So I know I'm multiplying it by 10 to the power of 6. And my decimal point's going to fall after the 2, and I need to have 3 significant figures. So that's 1 significant figure, 2 significant figures, 3 significant figures. So I don't worry about the 3 in this case. I would round, obviously, if the 3 was a larger number, but I don't in this particular instance. So now we look at the next one, and I have to move my decimal point 1, 2, 3 times there. So this is going to be 10 to the negative 3. So I end up with 4.7. That's my second significant figure, and I'm going to have to go 6 in this particular occasion. Because when I look at that 5, the next number is a 6, so I'm going to have to still round up. Those rounding rules still apply. So that's how we get those ones done. And then finally, I'll just do probably one of these, just showing you an example on the calculator of how to do these questions. So if I do 9.2105 times 10 to the power of 7, and I divide by 3.618756 times 10 to the power of 4, and that's how you're going to input those in. Now that gets me a number, so the first thing I could do is I could write that number down, put my calculator on my way, so 2545.211 or 212. Obviously that's rounded, so I won't use the equal sign, I'll use the approximately equals to sign. But of course, in this particular example, it wanted me to give that in scientific notation to 4 significant figures. So what I could do is I could work it out myself, or I could use my calculator and go Shift Mode. I go to scientific notation there. I choose 4 significant figures, and there's my number as I need it, 2.545 times 10 to the power of 3. And I'll leave you guys that B to work out. Make sure you input that into the calculator properly. Thank you. See you later.